Hello everyone. So we are here to present our case study on the Satkam electric scooter app. We have explored the key features, real user problems, and smart solutions to improve the app experience, from optimizing UX and document security to integrating AI, OTA updates, and better backend architecture. We focused on creating a smarter, safer, and more user-friendly EV app. Let's begin by looking at the key features and priorities that drive this vision forward. So, the company wants to do an analysis of the app and what it needs to improve it. Mind map the 10 features you would want in the app for the electric scooter and explain the top 5 features which would be the most useful. So, further expanding on this, here are the top 10 features. Live battery status with estimated range, predictive low battery alerts, Google Maps integration with real-time navigation, remote lock unlock, OTA, which is over-the-air updates, and document upload and storage. It includes DL, RC, etc. Ride analytics such as speed, distance, and eco score, maintenance reminders, and service center locator and appointment booking. Smart AI-based ride suggestions. And the other top 5 most useful features from us are live battery status with predictive low battery alerts, Google Maps integration, remote lock unlock, document storage, and maintenance reminder. So now the further, what are the some of the design consideration which would you consider for designing the storage feature and what all you will need to consider for security of the documents while designing the architecture. So our solution to this was design considerations like easy document upload through the app, sync documents securely with the vehicle dashboard, simple document retrieval while riding, supports multiple formats like PDF, JPG, and PNG and security measures such as use AES 256 encryption for stored documents, secure HTTPS connection for data transfers, two-factor authentication, 2FA for access control to allow verified user, use cloud storage with compliance to ISO 27001 or other equivalents. So my further teammate will handle.
So let us begin with the potential reasons for the two issues which customers have complained. So first issue, charge running out without warning. Potential reasons, poor battery health and estimation algorithm, app not syncing with scooter in real time, test scenarios, simulate battery usage till 10%, 5%, 2%, check warning system. Test real time syncing of battery percentage between apps and vehicles. Issue 2, UI of app is clumsy. Potential reasons are non-intuitive layout, cluttered UI, poor color contrast. Test scenarios, conduct usability testing with 10-15 target users, use heat maps to analyze click behavior, perform A by B testing with new UI prototypes. So now the top 5 things which we would like to do in inside of planning to release new app to the market and the outside in planning for releasing the new app. So inside of planning, company first focus, define app architecture with performance and scalability, redesign UI UX with a design sprint, collaborate with hardware team for seamless syncing, conduct internal testing and simulations, plan phase rollouts with internal employees as first users, then outside in planning, um, customer first focus, interview target customers for pain points, run beta testing with real users, analyze app store reviews for competitors, build community feedback loops for the app, market launch plan with clear messaging on new improvements. So now next teammate will handle the next topics.
So, hello everyone, I'm Netraj. Now let's look at the question number 5, which is based on the first, uh, based on the list of top 10 features you have selected. Do a relative priority exercise to mark them from P1, P2, and then from 1 to 10. explain what you have decided those priorities. So basically, we have divided them into two categories, P1 and P2. P1 features are directly related to safety, usability, and ride reliability, the essentials for a smooth rider experience, while P2 features are supportive and experience enhancing, but not strictly required in the MVP. That is the minimum viable product. So now let's look at the priorities, top 10 priorities which we have selected. So first priority is related to the category P1, which is live battery status with estimated range. It is crucial for every ride, and users need to know how far they can go. Then the second priority, which is also related to P1, is predictive low battery alerts. This will prevent getting stranded and enhances reliability. Then the third one is Google Maps integration with real-time navigation. It is key for urban riders to navigate effectively without switching apps. So the users will be able to use it easily without having to switch between the apps. Fourth one is remote lock or unlock. So the major safety and convenience features. It is the major safety and convenience feature, and especially in public areas. This feature of remote lock and unlock in the electric vehicle. The fifth priority, which is also part of P1, is maintenance reminder. The scooter will help maintain scooter health and prevent long-term issues. The scooter will basically give the maintenance reminders. The sixth priority, which is related to P2, is document upload and storage. This is useful but not critical. It is good for compliance and ease. Seventh is ROTA, over the air updates. This keeps the software updated but not needed frequently. The eighth one is the ride analytics, which is related to speed, distance, and eco scores. So this is good for tracking performance, but it's not essential for core usage. Ninth one is service center locator and appointment booking. This is convenient, especially during breakdowns, but not daily usage. So the tenth one is smart AI-based ride suggestions. This adds personalization. Again, it is not essential and can be added later. The smart AI ride suggestions can help give personalizations on the ride. Next, let's look at the sixth question, which is the company is collecting data in the cloud already, but had performance issues to update, collect the data, and update the app. What can be the reason for that, and what would we need to improve for data integration from vehicle to the cloud? And to send the data post analysis to the app. So basically, we are asked to give the possible issues for data synchronization between the vehicle and the app and improvement which we can add into it. The first issue is poor API response time. The API response time might be poor. The second is inefficient data modeling or high latency queries. Some queries might take high latency, or there might be inefficient data modeling in some cases. Third is improper cache management. Maybe the cache management is improper, and we can improve it. And the fourth is overloaded backend services. The backend services might get overloaded, which we might uh, uh, which we will be able to solve maybe using adding more servers or something like that. So let's look at the improvements which we can make based on the possible issues. Use edge computing for real-time data sync. We can use edge computing for syncing the real-time data, optimize APIs with pagination, compression, and reduce payload. We can optimize the API APIs so that the API time is reduced. Implement message queues like Kafka or other data streamlining. Message queues will make the caching easy. It will help the data modeling easy, and it will help the high latency. Next, for the caching layer, we can add a caching layer ready for repetitive requests, and basically we can just store data which is frequently asked in the caching layer, which is implemented by Redis, and we can use auto scaling cloud infrastructure. In order to scale the backend. So I would like my friend to continue further.
So moving towards next slide, which is about the smart app with intelligence and recommendations. So I am going to walk you through how can we can add intelligence and smart recommendations to the vehicles app using data and machine learning. So let's look at the kind of data the app should collect from the vehicle. Rider speed and route information, terrain type the vehicle frequently navigates, the charge cycles and current battery health, and the most importantly, the user's travel patterns like time, location, and frequency of the rides. With this data, our app can provide meaningful recommendations to the driver and some useful suggestion, which will be like the eco-friendly route suggestions based on traffic, battery saving driving modes, service alert, not just by time but based on the actual driving behavior, and smart charging device like optimal charging time slots or locating nearby stations. Now coming on the intelligence side, yes, there is a significant potential to use machine learning and AI here. Let me highlight few possible use cases. First one is predictive modeling of battery life, which is performed for the avoid breakdowns and rage anxiety. Smart maintenance and predictions, where we use past data and sensor trends. Personal ride insights using clustering, uh, and fault detection by applying anomaly detection to real-time sensor data. So our next slide, which question is containing the product solutioning, which is for the mind map of the new version of the vehicle. So in this slide, we have broken a new version of the vehicle using product and solution approach. So highlighting the goals, features, and improvements all the in both UX and UI. So our goals are primary goals, which will be to become a second in the market within a year and achieve zero key issues within a 6 months of launch. Drive 50% drive 50% increase in our sales and secure 10% of profit per vehicle. So features will be like for the supporting our goals, the features would be like fast charging capabilities, ideally bringing it under 4 hours and all, and modern touchscreen dashboard. Additionally, features like Google Maps sync and document sync, which will be enhancing utility. UX changes will be like a minimalistic layout that reduces cognitive load, improved menu navigation so users can access core features faster, and support for voice assistant, making the interface hands-free and safer while driving. UI changes. So for the user interface, we are introducing a high contrast theme for better readability in lighting conditions, an adaptive UI that switches intelligently between day and night modes, and improved iconography with a clear visual hierarchy to ensure initiative interaction. So, in conclusion, these product improvements paired with data driven intelligence in the app and position us to meet our business goals while delivering an exceptional modern and user experience. This is how we plan to not only stay competitive but truly stand out electric vehicle market. Thank you for your time.